Hello class, welcome to our lesson today dealing with graphs of tangent and cotangent. This is in section 4.3 in your textbook. Our focus today is that I'm going to show some equations of tangent and cotangent graphs and then show you what the graphs look like. To be honest, what you need to probably understand is how the graphs move and what will they look like. It's going to be less about drawing it yourself, so you want to make sure that you're understanding that as we go through these lessons. Let's first start with the graphs of tangent and cotangent. We did this a couple weeks ago with the graphs of the 6 trig functions. Remember, the tangent graph goes through 0, 0. At pi over 4, which is 45, it goes through 1. That corresponds to quadrant 4 being negative 1. And there's asymptotes at negative pi over 2 and pi over 2 because they're undefined because you can't divide by 0. There's no amplitude to the tangent graph. However, this point here at 1 and negative 1 kind of act as the amplitude. So if there was a 5, this would go up to 5, so it would go up faster, for example. The period here is pi, and for tangent, it's split evenly on each side of the y-axis. So pi over 2 and negative pi over 2 together make pi for the graph. And then you'll notice that I can repeat that graph over and over and over again, and that's why the period becomes pi, not 2 pi. The cotangent graph is similar, but it looks like it's backwards because they're reciprocals of one another. The amplitude is still nothing, even though 1 is kind of used in this case. The period is pi. But notice wherever tangent was 0, which was at 0 and pi, now it's an asymptote because you took its reciprocal. Wherever tangent had an asymptote, which is the divide by 0 issue, now it's going to be 0 as the reciprocal. It's important to notice, though, that pi over 4, 45 degrees, is still 1. Whereas 3 pi over 4, which is in quadrant 2, cotangent and tangent are negative. That's why it makes a graph that looks like this. So the key pieces, amplitude, there's none. We still use the amplitude to graph some things. And then the period to find it would be pi over b, not 2 pi divided by b in these questions. So you notice here that the only difference to this equation is that there's a 3 out front. There's still no amplitude, but it's kind of a 3 saying instead of at pi over 4 being at 1, it's going to be at pi over 4 up to 3. So it's going up faster and down faster as you're looking at that tangent graph in order to set it up and find the answer. Other than that, the period is still pi, so the asymptotes are still at negative pi over 2 and pi over 2. Again, your goal is probably to figure out, okay, which graph makes sense with this, with the period being pi. Okay, and so you want to look at those ideas as you're looking at your homework. The next graph is a 1/2 cotangent of x. Notice that this doesn't have an amplitude, but it's still a 1/2 involved. What that does is instead of going up to 1 at pi over 4, it's only going to go to 1/2. The period is still pi, so it's still at 0 and pi are the two spots, but it's going downward because it's a cotangent graph because it starts from positive to negative from quadrants 1 and 2. The next graph is tangent of 1/2 x. Now notice the b value is 1/2 here, so pi divided by 1/2 is actually 2 pi. And the way that this works for tangent is centered around the y-axis. So then when it's 2 pi, you need to go half in each direction, so it should go over to pi and negative pi. And that would become the whole distance of 2 pi. The 0 location is still the same, but then the 1 location, the amplitude, so to say, number, is now halfway between at pi over 2 and at negative pi over 2. So this graph is just stretched out compared to its normal counterpart of a period of pi and making it a period of 2 pi. The next example has a 1/3, so that makes everything shrink down. So instead of being at 1, it's at 1/3. And the period is pi divided by 2 in this case, which for cotangent, one of the asymptotes still stays at the y-axis, and then the other one just goes, well, how far over is it? So instead of going over to pi, you're going to go over to pi over 2, and then everything is about the halfway. So halfway in between that's where it hits 0, and halfway of those halfways essentially, which is kind of at these 1/8 locations, is where they hit up and down 1/3. Again, your focus probably make sure you know where where the period is, which is at 0 and then pi over 2 in this case, because pi over 2 is your period for this question. The next one has -3 plus 2 tangent of x. The 2 represents kind of the amplitude type number. The period is still pi, and I move everything down 3. This means the asymptotes stay in their spots at negative pi over 2 and pi over 2. But instead of being in these 3 locations that are written here, instead of being at 0, 0, it's down 3. Instead of being over and up 2 for the amplitude type number, it's down 3. Instead of being here at -2 at negative pi over 4, it's down 3 at -5. So this graph is just picked up and moved down 3. So the translation ideas are all identical to the sine and cosine graphs, but it's important to realize the pi divided by b versus 2 pi divided by b, and the asymptotes really will help you figure out where everything is located for tangent and cotangent. The next graph, the important thing is that this 4x plus pi has to be factored out. So this would be 4 out front and then pi over 4 in this spot for the phase shift of going left pi over 4, not left pi. That reasoning is exactly the same. You got to factor it. You got to take the 4 out and divide by it, just like we did in sine and cosine. Your amplitude is none, but you go up and down 3 in this case. It starts down 2, but the period is now pi divided by 4. So this graph really shrinks down. It's really hard to draw by hand. The important thing to realize is notice that if it's pi over 4, I went half of that way to the left and half to the right in order to find that solution, and that the middle ground area is 2 down from 0, 0. Those pieces should help when you're working with multiple choice scenarios. When you're drawing by hand, most likely you're going to have a little bit more space to draw out because it's hard to draw some things when the period gets so small. So keep those things in mind as you're looking at these questions. The key to this question is if you want to go left, okay, it's not left pi, it's left pi over 4 because you have to factor the 4 out in order to get that answer. So when you're dealing with tangent and cotangent, these examples should help in terms of figuring out the amplitude type number. Okay, remember there's still no amplitude because the graph goes up and down forever. But you can figure out what the period is, you can figure out the phase shifts left and right, and you can figure out if there's a vertical shift up or down. One thing that may show up is the flip over the x-axis, which would be a x-axis reflection. What would affect that is just being a negative sign in front of the amplitude number, which is the same as sine and cosine. Remember to focus on these ideas as you're looking at your homework, and don't forget section 2 as well. Have a good day, everybody.